Can you use a gradient of a graph of temperature over time to find the power of a heat source in a specific heat capacity equation? So in this question, we can see that initially the temperature on the graph doesn't change for a given amount of time. And that's usually because the kettle or whatever the appliance is that's heating up actually takes time to heat up before the water does. And so the water essentially only starts receiving the heat after the kettle and the heating element have heated themselves. And then you can see that you get a steady rise in temperature over a given amount of time. That change in temperature can be used to work out things like the specific heat capacity of the substance, usually water. In this instance, we're trying to find the mass of the water. And so we take the specific heat capacity equation, we take the amount of time, as you can see in the question, and we go to our graph and we find the change in temperature over 100 seconds, which is 100 minus 22 to give 77. Once we've got that, it's a relatively straightforward specific heat capacity question. You're just substituting values and rearranging to make m the subject, which most of you can do, but be careful, of course. And in the next question, this one's definitely a grade 9 question. They're asking you to find the power of the source that's used to heat the kettle from the gradient. And so for this, you've got to realize that the gradient is the change in temperature over a time interval. You've then got to take the two equations for energy in this instance, which is E equals PT and E equals MC delta. Well, I've called it theta, but capital T, theta, doesn't really make much difference. And what you do from there is by substitution, you put the equations, you combine the equations, similar to simultaneous equations, I suppose. And then you divide the time interval to the other side of the equation, collect the constants, which is mass and specific heat capacity. And then you can see that the power depends on the rate of change of temperature, which is the gradient of the graph. So I hope that helped.